Hi guys, welcome to section B of chapter 6. We're going to talk about viruses today. Viruses are very simple structures, way more basic than the bacteria that we talked about, okay? They are basically DNA or RNA surrounded by a protective shell. You can think of viruses as like an M&M. The chocolate is the DNA and the candy coating is the protective coat around it. We call that protein coat, that protective coat, a capsid. Let me get my pen here. There we go. I love this structure. This is called a bacteriophage. Basically, it's a virus that infects a bacterial cell. Totally looks like a little alien spaceship, doesn't it? Anyway, the viruses are not considered cells at all. They don't have any organelles. It's literally nothing more than the nucleic acid, the DNA or the RNA, and that protective shell. Okay, they're not considered living organisms. And another kind of drawback, I guess, for the viruses is because all they have is the DNA. They don't have the ribosomes. They don't have anything to produce their proteins. They need a host cell in order to produce proteins. Okay, and we'll talk about that viral reproduction in just a second. You can see two different structures here, and there's actually additional structures in this. One is a DNA filled virus, and this one has RNA. They both act very similarly. This structure is for the influenza virus. It also is very similar to what the coronavirus, the COVID-19 virus looks like. I'll show you a picture of that at the end, okay? All right, so now let's talk about this viral reproduction. Don't worry that that I'm blocking this description here. In fact, I'll move it so you can see it a little bit in case you want to read that. So because the virus needs this host, it's a little more limited, okay? So the virus attaches to the host cell, okay? And it either directly injects the DNA into the host or the virus is engulfed by the host, okay? The bacteriophage, that little spaceship looking one, it attaches to the outside of a cell and it kind of injects its DNA directly into it. This RNA virus here kind of gets swallowed up by the host cell itself, okay? Once the DNA is in there, it hijacks the nucleus of the host cell, okay? So the DNA will come out, or the RNA will come out of the virus, and it will insert itself into the DNA inside of the nucleus, okay? Because the DNA and the RNA is coding for proteins, that's what the new cell is going to be doing, okay? It literally takes over the function of the cell so that it can make new virus parts, okay? So the DNA or the RNA from the virus has the instructions for the parts of the virus, takes over the host cell, the DNA is being replicated, it's going to the ribosomes, and it's making those specific proteins. Those new virus parts will assemble into brand new viruses, and eventually they will burst out of the cell. They rupture the cell when they do that, and that's why we get sick, because the virus is actually damaging our cells, okay? There's lots and lots and lots of different diseases caused by viruses. This is just some of them, okay? There's our coronavirus right there. Lots of things you probably recognize from maybe some of the vaccines you've taken, like HPV or mumps, measles, things like that, okay? There's not a lot we can do in regards to treating viruses. A lot of the viruses, we just have to treat the symptoms, okay? There are antiviral medications. I think I talk about that on the next slide, but they just aren't used as often. And keep in mind that antibiotics are only for bacteria. Antibiotics won't do anything to help with a viral infection, okay? So the best thing we can do is prevent the infection to begin with. And good hygiene is the best for that. I know you've heard about this like crazy with the coronavirus going on. Washing hands, don't share food or drinks, and keep your hands off of your face. Because when you touch things, you get bacteria and viruses on them, and you touch your face, it can get in your eyes, get in your mouth, and then your nose, don't pick your nose, things like that, okay? So fighting infections, again, the hygiene is super important. There's specific instructions for washing your hands. It requires more than just, like pretending. Take care of your immune system, though. Your immune system fights against these viruses. So make sure you're getting plenty of sunshine. The vitamin D in sun is excellent for immune health. Plenty of sleep. If you're tired and stressed and run down, your immune system just doesn't work as well. Okay. Again, there are those antiviral medications. They're just not, I don't know why they're not as commonly used. I don't know if it's because they're not a sure thing. I don't know if it's because they're expensive. I'm not sure why, but it's just not something that's easy to get. They do exist though. Part of the prevention of getting a vaccine, getting a virus, is to get vaccinated against the virus. There are also vaccines against some of the bacterial infections as well. But what a virus is it's actually a weakened version or a dead version of the virus. Okay, so if you remember that funky shape, right? We had that funky virus-looking thing over there, and it used to have the DNA in it, right? Well, if you have just the empty coat with no DNA inside of it, that can be put into your body. And it tricks your body into thinking you've been infected. Your body's going to recognize the outer coat of this. But since there's no DNA inside of it, it can't make you sick. What it does is it promotes your immune system to build up its defense against this in case you're infected by it for real. We'll talk about that more when we actually cover the immune system, okay? So here's COVID-19. This is a picture of what it would look like. It actually, its proper scientific name is SARS-CoV-2, and that stands for Severe Acute Respiratory Syndrome Coronavirus 2. And the 2 is because it's actually the second version, okay? We've already had a SARS-1. It was just known as SARS, and that one was nowhere near as contagious as this one. Only about 8,000 cases worldwide, but 1 in 10 people died from it. So it had about a 10% mortality rate, which is way higher than the COVID-19 that we're dealing with now, the second coronavirus. SARS-CoV-2 has, this was as of August of this year, 2020, has about 25 million cases worldwide. And so that breaks down, it's hard to come by data with this because it's been so politicized. It's really difficult to know how accurate our numbers are. Have people died from COVID or with COVID? There's a lot we're still waiting to learn. But even if you take every single, what we think is a death from COVID, that puts the mortality rate much lower than this first one, okay? Still a worse mortality rate than the flu. The seasonal flu has a mortality rate of less than 1%, okay? Wash your hands, keep your immune system up. We're gonna be okay. Oh, and the last little fun fact about the COVID-19 coronavirus is that it is an RNA virus, not a DNA virus. All right, that is all.